Welcome everybody. We're back. We're dealing with hyperbolas, and we're going to see what a hyperbola is. Many of you may not have seen these before. It's our last type of conic section. Remember, this is the type of conic section that was that cut both of the cones, both of the double nate cones at the same time. So you're going to get two pieces of a graph. And let's see what this is. Bam. So that's what it is. So you can picture my plane is right here, just cutting it in half. You get two pieces of the cones, one down low, one up high, or in this case, one to the left, one to the right, depending on how your cones are oriented. Okay, so let's start taking a look at these equations and how they're different. For starters, one of the things that we need to deal with is that there's no minus sign right here. You need to put a little minus sign. So let's take care of that. And the couple of things that are the same as the ellipses is the H and the K are still your centers. The H and the K are still your centers. And this time, instead of A, the biggest one, controlling which way it's going, your A is no longer the biggest one. It's the one underneath the first, whatever comes first. In this case, X comes first. Over here, Y comes first. The reason being is the minus sign makes the difference. Okay, so when X is in front, I have a hyperbola that's going left and right. When the Y is in front, I have a parabola that's going up and down. Okay, so in these separate cases, let's take a look at what each thing is. Your A distance is from center to focus. Center to vertex, excuse me. A is from center to vertex. That hasn't changed. Okay. B is from center to some little point up here. Dink. There's B. And 2 point perpendicular to transverse axis. What's the transverse axis? Right here, transverse axis is the if you will, it's what we used to call the major axis. It's the one that is going, that's controlling which way my hyperbola is going. The one going up and down in this case is your conjugate axis. Okay, we'll talk more about that in a second. C, okay, this time our relationship here with C is the C part is still my distance from center to focus. Again, that hasn't changed. And notice the relationship for C has also changed. Instead of being C squared is A squared minus B squared, it's now C squared is equal to A squared plus B squared. Again, no relation to the Pythagorean theorem. Okay. All right. I think that's fine, but let's talk about it from over here. Just so you go in vertex to center, there's your A distance. Your B part's way out here. And your C is from center to focus. Now, what's kind of cool about the A and the B is it makes a rectangle. And when it makes this rectangle, this is how we're going to build our hyperbolas. Because one of the cool things is, if you notice, these asymptotes that the hyperbolas are on are the diagonals of this rectangle. And the vertex is tangent to that rectangle. All right, so let's build this out and see where we can go. Okay, and again, transverse axis on this one is up and down. Conjugate axis is left and right. Okay, so you may want to write this down as that transverse axis is vertex to vertex. Let's go on and see how we can build one of these. So here they go. So what I know about this is that X is first. Since X is first, I know that my graph in my brain needs to be looking something like that. Okay? That's what in my brain I'm thinking this because X is first. Since X is first, whatever's first, this again is here's my A squared is equal to that. This is my B squared. What's my center? My center, oh, there's nothing there, so I'm going to write that down. Center. I'm at 0, 0. So let's start graphing what I know. Center is 0, 0. That's easy enough. Boom, right there. My transverse part. Okay, so from here, what is A? That's easy enough. A is equal to 7. And B is equal to 9. So over here I go out here in 7. So 1, 2, 3, 4, 5, 6, 7. So I'm just going to call that 7. Come out here to negative 7. And since this is my A, this is my first one, these are my vertexes. Then the next part is B. I make B. B is up at 9, so start at 0, count up 9, and 9, down negative 9. And this is right at this point, I can make the little box that I had seen before. I make a little box, I make a straight line here, straight line down, straight line over, straight line up, finish it up. There's my box. And from there I draw the diagonals. I can get my card out, or you get a straight line tool so that I can go ahead and make my straight line. Close enough. Make this straight line. Close enough. So let's go through my the diagonals of that rectangle. I go ahead and get back here, and I'm going to draw in my hyperbola, which is my X, and it comes in close, comes out close, comes in close, comes out close. And again, that's all I'm looking for. I'm not looking for detailed graphs, guys. All right. The last part is to find my focus, and so that's my C. So again, C squared is equal to A squared plus B squared. I just plug in. That's equal to 49 plus 81, which is equal to 130. That's C squared. C is equal then to the square root of 130. You go, and if you need to for your calculator, it's about 11. So out here, there's my focus number 1. That's square root of 130. And my focus number 2 is out over here at negative square root 130. All right. Fun. Hopefully we can try this again. One more time. So again, now I have this one. So when I look at this one, I'm looking, which one is first? Y is first. So again, Y. So that means in my brain, I'm thinking I've got something that goes up and down like this. Just again, getting the picture in my head. So then when I go ahead, I'm going to go find my center. My center, again, remember it's all Bizarro world backwards. My center for this one is the X coordinate, which is, instead of being negative 2, it's positive 2. Instead of being positive 4, is negative 4. And again, I identify what's A. That's A squared. That's B squared. So that means that A is equal to 2. B is equal to 3. Let's start drawing this out. My center is 1, 2, 1, 2, 3, 4. There's my center. And now I need to go again, A. Well, again, the picture of my brain tells me it's going up and down, so it just means that A is now my up and down part. So A is now 1, 2. A now is going 1, 2 down. And this here is my transverse axis because I know it's going to go, that's my, if you will, the major axis. It's telling me which way it's going. And let's see here, B is 3, so I count over 1, 2, 3. And let's get that lined up better. Count over 1, 2, 3. And I can go ahead and make my box. Boom. And again, I make my diagonals. I'm not going to be as precise this time. And again, I have to be thinking of that picture in my brain. The picture in that brain tells me, oh, it's going to be here. Get really close to those. There it is. Again, finally, I need to go find my focus length. My focus, again, so C squared is equal to A squared plus B squared. C squared, excuse me, is equal to 4 plus 9, which is equal to 13. So C is equal to square root of 13, which is a little less than, a little bit more than 3, between 3 and 4. So 1, 2, 3, 1, 2, 3, here-ish, not quite up to 4. There's my focus. 1, 2, 3, not quite up to 4. There's my focus. Ta-da. Alright, so now these are the easy ones because they give me all the information. The next ones, they're going to give me pieces of information. I need to go find the other pieces. They're not going to give me the whole equation. I have to go find out what that equation is. So here we go. Oop, I don't want to do that one. This one here says, write an equation for hyperbole with a foci and the transverse axis length of 4 units. So let's go ahead and graph what I've got. Graph what they give me. When you graph what you give me, I got 1, negative 5, 1, 2, 3, 4, 5. There's focus number 1. And then up here it's 1, 1. There's focus number 2. So what do I know about this? Well, my focuses are up and down. That means that in my brain, again, I'm thinking, oh, it's going to be like this. So in my brain, I'm thinking that this is going to be y minus k squared. Again, I'm getting this just from the top, over a squared, because it's going to be y is first, so a goes with the y. X minus h squared over b squared is equal to 1. So that's what I'm going to go with. All right, so what do I know? I know that this whole length from focus to focus is 6. So what does that tell me? So center to focus is what C is. Remember, C is center to focus. C is equal to center to focus. Oh, so that means this whole distance here of 6 is equal to 2 C's. So I know that 3 is equal to C. So that means if I count up and down 3, 1, 2, 3, 1, 2, 3, there's my center. And I find my center at 1, negative 2. And right there, there is my H and K. So now the only thing I have to do is find A and B. What do they tell me? They tell me my transverse axis, and remember transverse axis is the up and down one, has a whole length of 4 units. That's the whole thing. So that means that half of my transverse axis is 2. So my whole transverse axis, remember that's going to be 2A is equal to my transverse axis, 2 times the distance from center to vertex. Because remember, transverse is from vertex to vertex. Okay, so 2a is going to be equal to 4, which means that a is equal to 2. Okay, so a is equal to 2. I count up 1, 2. There's my vertex. Count down 2. There's my other vertex. I'm almost there. Only thing left I have to find out is how wide they're going to be with the b part. How can I possibly find that out? I find that out by doing the c squared is equal to a squared plus b squared. In this case, c is 3, so c squared is 9. A squared is 4 plus b squared. Subtract, take the square root. The square root of 5 is equal to b. Oh, so the square root of 5 is b, so that's a little bit more than 2. 1, 2, a little bit more. 1, 2, a little bit more. Oops, I didn't go far enough out on this one. Okay, should be about there-ish. Alright, so now I go ahead and make my box. I make the box being here. Down, going to my vertexes. Going to those parts out there to B. My diagonals get formed by the my asymptotes get formed by the diagonals. And then finally, I draw it in, draw it in, draw it in, draw it in. There you go. All right, so I had, I still need to go ahead and write my equation based off everything I've got. And here we go, y minus k, so it's going to be y minus 1. Oop, not 1. Y plus the 2, that's the y coordinate. Okay, the x all over a squared. So a in this case was 2, so a squared is 4. Plus, no minus, excuse me, x. Okay, my center minus an h is a 1. Oop, can't forget my squareds. All over b squared. Well, what's b squared? B was square root of 5. 5 is equal to 1. And that's my final answer. We got one more to go. Let's get ready to do it. All right, so this is our last equation I'm going to write for. This is here, write an equation for the hyperbola with a vertices of -3, 10 and -3, -2, and a conjugate axis of length 6 units. Conjugate axis, guys? A conjugate axis is, that's the side that does, the axis that does not have the vertices on it. So let's go ahead and draw this out. So when I draw this out, -3, 10. So here I am at -3, 1, 2, 3, 10. I got that way up here and label it 10. It's right here. And -3, -2, 1, 2, here. So just from this alone, I should be able to find my center. My center is going to be halfway between here, so between 10, -2. And I can find out that there's 12 units for the entire transverse axis. So it means halfway, or 6 units, will get me the center. So here, if I drop down 6, that puts me here at 4. And there's my center. My center then is at -3, 4. And what I can tell right away is they tell me these are my vertices. Okay, these are the vertices, so that means that my parabolas are, my hyperbolas are up, down, up, down. So that means it's going to be a y minus k squared over a squared minus x minus h squared over b squared is equal to 1. So I need to go find my a and my b. My a is the distance from the center to the vertex. Center to vertex is 6, so A is equal to 6. And then they say my conjugate axis is a length of 6 units. Well, my conjugate axis is from side to side. So my conjugate axis tells me that 2B, because that's the whole length of my conjugate, is equal to 6. So that means that B is equal to 3. And I can count out here 1, 2, 3. 1, 2, 3. And now I have the makings of my box. But I don't even need to draw it out there because they're not asking to, they're just asking me to write the equation for it. But I'll do it anyway. So I draw my box. Here's my box I'm drawing. My diagonals of my rectangle are the asymptotes for the hyperbola. And then here's my, there's that. There's that. Ta-da. There it is. Now I need to go ahead and have the formula. Again, here's my center, HK. Center is a y minus 4 squared all over a squared. A is 6, so it's 36. Minus k x minus h, x minus negative 3. So it'll be plus a 3 squared all over b, which is 3, which is 9, which is then equal to 1. And there we go. That's how we do that. Cool. Last thing we have on our list, our last little problem we have, is to determine the eccentricity. And so the eccentricity, you gotta remember that. Again, eccentricity is E is equal to C over A. So I need to find out where C is, and I need to find out what A is. Again, remember when you see the minus sign here, and it's a hyperbole, it's no longer, A is no longer the biggest one, it's the first one. Okay, so there's my A squared. And so A squared, so that means that A is equal to the square root of 32. C, well, I would do C, I understand now that C squared is equal to A squared plus B squared. So C squared is equal to 32 plus 25, which is then equal to 57. Take the square root. C is equal to the square root of 57. Put it all together. It's equal to E, square root of 57, over A, the square root of 32. And there's my happy answer. That's all we got. All right, guys. That's it. Thank you for sticking with me this long. We'll see you guys next time. Bye.